Okay, looking at the first one. It says use the information provided to write the standard form of each ellipse below, and you only need to graph it if needed. I like to have a graph because the graph usually helps me find the center. I can count down in different directions, but if you don't need the graph, you don't need to use it. It's fine. So ellipse standard forms, remember they do have two different directions that they can face, and it's based on the larger of the two denominators. If it's larger under x, it's going to be facing horizontal. If its larger number is under y, then it's going to be facing vertical. So looking at our first one, we're told the vertices and the foci. The fact that they use vertices and not co-vertices does tell me that these are the ends of the longer axis. Ends of longer axis. Whereas if they would have said co-vertices, that would be the ends of the shorter axis. Okay, so I'm going to start just by plotting the information I was given. We do have one vertex at -4, 13. 1, 2, 3, 4. 13. I'll just label it with a little v for vertex. And then another one is at -4, 3. And then we're also told the two foci. And the foci should be on the longer axis, so ideally the foci should be lined up with these. Let's see, -4, 11. That's 2 under this one. And then -4, 5. Okay. So if we set up just like the basic standard form, an ellipse should have a plus sign in the middle of its standard form, and then it'll have two fractions. So I'm just going to set that up. Plus sign, two fractions. It'll be equal to a 1 on the right-hand side. For each of those fractions, I know that it's going to have some sort of either like x minus h squared or y minus k squared. So I don't know the center yet, but in a second I will be able to figure out and put in my h and k numbers, and then we'll be able to figure out our two denominators. Okay, how do we find the center from what we have now? Pretty easy. Just count, yeah. If you want, you can use the fancy midpoint formula, which you would add the two x's together, divide by 2, add two y's together, divide by 2. But it looks super easy to just find the center. You can literally just count it down. Let's see. This guy right here would be our center. We just got to figure out what ordered pair is that. What ordered pair is that center at? -4, 8. Okay. So once we know the center, we can put that in as our h and our k in our equation. Which one pairs with x, the h or the k? 8. No. Yes, h. Whereas k always pairs with y, no matter if you flip the two fractions. So in my first parenthesis here, what am I going to write? X plus 4. X plus 4. And in the y parenthesis, we would put y minus 8. Okay. Now I can easily figure out the number that should be under the y variable, because I can actually see how much we need to count to go from the center to the vertex. This number right here would be our a variable. That's our larger denominator. And again, that will go under the y on this one, because that's how much we're counting in the y direction. How much are we counting in the y direction? 5. A is 5. So then underneath our y variable, are we going to put a 5? 25, right, because this should be our a squared. 25 is our a squared. And then the other one would be b squared, but we can't find that right offhand because we don't know how much we counted in the x direction. They didn't give us co-vertices to figure that out, but we can use how much it is to get from the center to the focus. That would be a distance of c. So center to the focus, c is, how much would that be? 3? 1, 2, 3. Yes, c is 3. And then do y'all remember the formula to find c for an ellipse? Is it a squared plus b squared or a squared minus b squared? It's minus. Anytime there's a plus in the equation, you're going to subtract to find your c. So c squared equals a squared minus b squared. which is basically just larger denominator minus smaller denominator. I know my C was 3, so I'm going to say 3 squared equals, my A was 5, and we're solving for the B. That would be 9 equals 25 minus B squared. If you subtract 25 on both sides, you get negative 16 equals negative B squared, which means B squared is 16, which means B is 4. Now, in our equation, do we need B or do we need B squared? B squared. So in here, we want to put our 16. The 4 would be what you would use if you actually wanted to finish graphing this. If you wanted to finish and actually find your covertices, you would count from the center, 4 to the right, 4 to the left, and then draw in your little egg shape here. But only graph it if you feel like you need to graph it. Like we honestly, the graph is not as important as the equation on this one. All right, what's different about the second one? Covertices, yes. They give you foci and covertices. Covertices are going to be the ends of the short axis. Ends of short axis. Okay, they do also tell us the foci, which should be on the long axis. So ideally, when we graph these, they're not going to like line up properly. Hey, Adon. Okay, plotting the foci first, we have 1 at 10, 6. 1, 2, 3, 4, 5, 6, 7, 8. It's 10 all the way to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. 1, 2, 3, 4, 5, 6. There's one focus. And then negative 6, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Hardest part about this is basic counting. Okay, and then plotting my covertices, I have 1 at 2, 12. 2, 4, 6, 8, 10, 12. And then another one at 2, 0. Okay, and again, just setting up my basic form for an ellipse. It'll have a fraction, a plus sign in the middle, another fraction. What's it equal to on the right? 1, good. And then we'll have some sort of, always got 2 parentheses squared. One will be x minus h, one will be y minus k. So we got to figure out our hk and then our 2 denominators again. All right, how do we find our hk again? Yeah, just count till you find it. Count till you find the middle. If you want to, you can do midpoint formula for either of those, but not needed. Honestly, you just count down with the covertices, or you can even count down with the foci. It also kind of lines up perfectly between all of them. Looks like it's this point right here is our center. What is that ordered pair? Yeah, 2, 6. Very good. Okay, so we can put our h and k in our equation now that we know that the center is at 2, 6. Which one are you going to write with the x? Negative 2. And with the y? Negative 6. Okay, and then if these are the covertices, again, these should be the ends of the short axis. So if I were to count this amount, number 1 is going to be b, because it's the ends of my short axis. But which variable are we going to put that under? Y. Very good, because we counted up and down. So how much we counted up and down will be our b. Anyone count it yet? What'd you get? 6. Very good. So if b is 6, that's going to go underneath y, because that's how much we counted in the y direction. Do we put a 6 or do we put something else? 36, right, because it should be your b squared. Okay, how are we going to find our a squared then? How much we counted in the x direction? Yep, we got to do a little c squared equals a squared minus b squared. Our little foci equation. We know the b amount, and we can easily count the c amount. C is how much we counted from the center to a focus. This would be our c amount. C is how much? Yeah, but how much is 10? Or how much is c? 8. Very good. Alright, let's substitute that in. So we'll have, let's see, 8 squared, that's 64, equals my a squared minus my b squared, that would be 6 squared, which is 36. So a squared, if you add 36 to both sides, a squared is 100, and then a would be 10. In our equation, do we need the 100 or do we need the 10? You need the 100, right, because this should be your squared variable. If you wanted to finish graphing it, you would use the 10. You would, from the center, count 10 right and 10 left to find the vertices. But only graph it if you feel like it. All right, what shape are we working on in the next section? Hyperbolas. Very good. Hyperbolas, if you look at your chart, the equations are similar to ellipse. It is still a fraction and another fraction equals 1, but instead of having a plus sign in the middle, it'll have a minus sign in the middle. Also, whichever term is the positive term is based on which way it faces. So if it faces left and right, the x would be the positive term and the y would be the negative term. But if it faces up and down, the y is the positive term and the x is the negative term. I think about horizontal like the x-axis, so x would be first. Vertical like the y-axis, so the y would be first. And then the way you find c is slightly different. When there's a minus sign in the actual standard form, you're going to add to find your c squared. We'll have to remember that. Okay, let's look at what we're given. First one, we're told vertices and foci. Okay, I'm going to go ahead and graph those vertices and foci. Vertices at 7, 15. 6, 7. Again, hardest part of today is literally just counting. This is these tiny lines. And then 7, negative 9. Okay, and I'm also told foci, one is at 7, 18. So 15 was right here. 16, 17, 18. And the other would be at 7, negative 12, which should be 3 under the other one. 10, 11, 12. Okay, so setting up our equation, remember we have a fraction minus another fraction equals 1. We're going to have some sort of parentheses squared, some sort of parentheses squared, but I'm going to wait to write in my x and y until I can figure out which way this faces. Okay. Can you tell based on where the dots are which way this one is going to face? Up and down, right. Vertical, because you have the focus that's going to be inside the little cups of the hyperbola. So if it faces vertical, can we tell which should be the positive term and which should be the negative term? Y term is positive. Very good. Okay, so I can write that in my equation. I can go ahead and write the y as the positive one and the x as the negative one. What else can we find from here? The center. Yes, center. Again, you can either count down from the two vertices until you find it. You can also use the midpoint formula and add the two x's together. I guess you would add these two together and divide by 2. And then you would add the two y's together and divide by 2, and that should tell you the midpoint. Either way, what are we finding for that midpoint? It is definitely 7 something. 7 what? 7, 3. Very good. 7, 3 is our center. Okay, and then can we put that in our equation as our h and k? Okay, so be careful which one is paired with the y. Is the h or the k paired with y? K is always paired with y. Very good. H is paired with the x. So we'll have minus 7 with the x and minus 3 with the y's. Okay. And then to figure out my two denominators, I'm going to use the fact that I know how much I counted from the center to the vertex, and I can also see how much I counted from the center to the focus. So I'm going to use those two numbers. And then center to the focus. Okay. Center to the vertex, that would be going from 3 to 15. 3 to 15 would be a difference of, what is that, 12? So it would be how much I counted in the y direction. I believe that's just A. A is 12. And then from center to the focus would be a distance of how much? 15? Okay. So the distance from the center to the vertex, this is how much we counted in the y direction. So we can put in the y denominator. What would be my y denominator? Is it 12? 144, right, because it should be our a squared. Okay. And then to find our b squared, we're going to use our little Pythagorean theorem equation. Again, for a hyperbola, you are going to add to find your c squared, whereas it's different for an ellipse, you subtract to find your c squared. So our equation would be c squared equals a squared plus b squared. Yep. C squared, that would be 225, 15 squared. And then that would be 144. And then we'll subtract to find b squared is 81. Do I need b squared or do I need b? We need b squared. Very good. So my denominator over here will be 81. If you wanted to finish it, you would count from the center 9 in the x direction, 9 left, 9 right. That would get you that center box. If we don't remember that, it gets you, and then you draw the parentheses, or you draw the box around that. But they only wanted the equation. All right, next up, kind of similar. Again, given vertices and foci, so similar pieces of information. I'm going to start again just by graphing my vertices. One is at 5, -1, and one is at -1, -1. 1, 2, 3, 4, 5, -1, and then -1, -1. Okay, and I'm also told my foci, one is at 7, -1. And then another at -3, -1. Thinking about just our basic equation, again, for a hyperbola, you have a fraction. Do we have a plus or minus in the middle? Plus or minus? Minus in the middle for a hyperbola. Minus. You'll have another fraction. What is it equal to on the right? 1. And then I don't know if it's x or y yet, but I do know we have parentheses squared on both the top and bottom. Okay. So looking at the direction it's going to face based on just the points. Can we tell which way it faces? Yeah, left and right. It's going to face horizontal. Faces horizontal. Okay, which makes me immediately think about the x-axis, telling me that the x is the positive term. I think about the horizontal axis. X term is positive. Okay, so I can go ahead and write in, at least now I know that this should be an x as the positive one and the y is the negative one. Okay, and then figuring out my two denominators and my center is what's next. Okay, center should be pretty easy. We just need to count it down. Anybody figure it out yet? 2, -1. That's our center. Okay, which are our h and k. Which one is paired with the x? The 2, the h. Very good. So what are we going to write in the x parenthesis? X minus 2. And what are we going to write in the y parenthesis? Y plus 1, because minus on the negative 1 would turn into a plus 1. Okay, so still figuring out our two denominators. Again, we have to use the fact that we know how much it is needed to get from the center to a vertex. And we also know how much it is to get from a center to this focus here. So that kind of gives us two numbers to use in our little a squared plus b squared equals c squared. All right, let's do some counting. Center to vertex. That's basically how much is going to be under the x term. Okay, that one is a. And that's just 3. Okay. So if a is 3, since we counted in the x direction, what are we going to write under the x term? If If a was 3? 9. Very good, because you write your a squared. The other one will be our b squared. And we'll need to actually calculate that one using our little c squared equals a squared plus b squared. Okay. How much do we count to get from the center to a focus? That would be our c variable. 1, 2, 3, 4, 5. C is 5. Very good. All right, we can get those substituted in. 5 squared, that would be 25 equals 3 squared. That's 9 plus b squared. If you subtract 9 on both sides, you get b squared equals 16. So b would be 4 if we wanted to finish graphing it. But what are we going to write underneath our y variable? 16, our b squared number. So definitely kind of gets you thinking about all the basic shapes of these conics again, because I know the only one we've done recently is a parabola. Okay, flipping it over, we got 2 more hyperbolas, but with different information. Okay. This one's talking about foci and the asymptotes. Different information. All right, I'm going to plot the foci. I have one at 4, 15. And then I have another one at 4, 5. Okay. Now what I'm not going to do, I'm not going to actually draw in the asymptotes. I'll kind of show you how we can use the asymptotes to find information we need, but I'm not going to waste time like actually graphing them. You can do that if you want to. Okay, since this is a hyperbola again, I'm just going to set up my basic form. A hyperbola has a fraction minus another fraction is equal to 1. We'll have some sort of parentheses squared, some sort of parentheses squared. Can you tell which way this faces based on the fact that the foci are stacked up and down? Vertical. Very good. It would have one branch of the hyperbola this way, one branch of the hyperbola this way, but it does face vertical. So I immediately think about the vertical axis. Which one is the vertical axis? X or Y? Y, which tells me Y is the positive term. Y term is positive. Okay, so that means Y will be first, X will be second. What else can we find from here? The center. Yeah, the center. Anyone figure it out yet? What is it? 410? Yep. 1, 2, 3, 4, 1, 6, 7, 8, 9, 10 is our center. Okay, so those are my h and my k, which I can put in my equation. Which one do we write with the y? K, right. So we would write y minus 10, and we would put x minus 4. Okay. Now to figure out our two denominators, we don't have enough information to figure that out based on this graph right here, okay? Because all this would tell us was c. We don't have a way to find a or b based on this graph, but we do have our two asymptotes. And the slopes of the two asymptotes are basically the important part. The slopes of our two asymptotes are going to help us figure out how much we had counted underneath x and how much we had counted underneath y. So if I think about this first asymptote right here, its slope was 3/4 x, which tells me how much I counted in the rise direction, which would be the y direction, and the run direction, which would be the x direction. Okay, so if we think about the slope as a rise over run, the rise again is how much we counted in the y direction, and the run is how much we counted in the x direction, because rise is the change in the y's, run is the change in the x's. So from there, I can literally figure out my two denominators. So looking at this right here, how much we counted in the y direction. We counted 3 in the y direction. But does 3 go under my y variable? What goes under my y variable? 9, the 3 squared. Okay. The other one would be our b squared, and we're going to look at that by looking at how much we counted in the x direction. We counted 4 in the x direction, which means underneath the x variable would be 16. Okay. Again, if you wanted to finish graphing it, you could use those numbers and count, 3 up and 4 over. You would use the negative slope on the other side, and eventually you would get that little center box that we draw for hyperbolas. But it didn't care about that. It just cared about the equation. All right, second one is the same. We have, not so pretty foci numbers. That's okay. Square root of 13, -1, and negative square root of 13, -1. What is square root of 13 approximately? No calculator needed. Just find your closest perfect square. 3.5-ish, yeah. Because square root of 9 would be 3, square root of 16 would be 4, and then square root of 13 is kind of halfway in between. So one of them is at 3.5-ish, -1. And the other is at negative square root of 13-ish, -1. So like negative 3.5-ish, -1. Okay, if we think about just the standard form of this again, we'll have a fraction minus a fraction equal to 1. Okay, we'll have some sort of parenthesis that's squared, some sort of parenthesis that's squared, and then trying to figure out, can you tell which way this one faces just based on the fact that the foci are left and right of each other? Horizontal. It is going to face horizontal. Which axis is the horizontal one? X or Y? X. So now I know that X is the positive term. Okay, so X would go here, Y would go here. Okay, can we find the center of these two foci? Yeah. This is the center. What is that point? Yeah, 0, -1. Okay, which are going to be my H and my K. So what am I going to write in the X parenthesis? You can write -0. You can also just not write it also and just write X squared. But in the Y parenthesis, what are we going to write? +1. Again, feel free to write the 0 if you want to. You can also just leave it blank. Okay, again, we can't necessarily count using the foci to find our denominators, but we can use these two slopes. Okay, because those slopes were basically how much we counted from the center to find that little center box. Thinking about them as rise over runs, just like the last one. The rise is 3, the run is 2. Is rise X or Y? Y. So then is run X or Y? X. So then that kind of helps me figure out which denominator they need to go under. Okay, starting with the rise, it was a 3. So underneath the Y variable, what are we going to write? 9. And then underneath the X variable, we're going to write 4. That's our A squared, that's our B squared. All right, and then last shape is the most current one, okay, which is the one we did most recently. So this one we might actually remember. Standard form of a parabola is the last one. I'm going to start just by graphing what I'm given. I have a vertex and a focus on the first one. Vertex and a focus. Vertex is at -4, -2. Okay, and then focus is at -4, -7. Okay, So remember, for a parabola, these can face up, down, left, or right. Just based on the way it's graphed so far, can you tell which way it faces? Down. Yes, it is a down one because the focus needs to be inside the little cup of the parabola. So we know it faces down. So facing down tells me two things. It should tell me which variable is the squared variable, and it should also tell me if 4p is positive or negative. Okay. If it faces down, does that mean x is squared or does that mean y is squared? X is squared, which is normal. For a normal quadratic, x is squared and it creates up or down. Okay, x is squared. And then that should tell me if it faces down, is the 4p going to be positive or negative? Negative, because it's downwards. 4p is negative. Okay, so I'm going to set up, usually I have the squared term on the left, and then I'll have my 4p as the coefficient, and then my unsquared term on the right. Okay. So if it faces down, we know x is the squared term, so x should be here, y should be here. 4p we know is negative something. I just don't know the something yet. Do we know the h and k to put our vertex in? Yeah, they were literally given to us. This hk right here, or this vertex, is your h and k, which should go in with your x and your y. So in the x parenthesis, what are we going to write? Plus 4. And in the y parenthesis, we're going to write plus 2. And then the last thing we got to figure out is just how much the 4p is. We know it's negative something. Any way to find that? Find the difference between the vertex and the focus. This amount right here should be p. Just regular old p. What is that number? 1, 2, 3, 4, 5. 5? P is 5? Okay, so if p is 5, what number is going to go here? 20, 4 times p. And we already knew it was negative because it was facing downwards. Okay, and then last up, similar information. This one does tell us the vertex and the directrix though, instead of vertex and focus, but it kind of is used the same way. Okay, so starting with, I'm going to graph my vertex at positive 8, negative 5. Okay, and then directrix is x equals 15 over 2. 15 over 2, okay, so x equals at least tells me it's vertical. What is 15 over 2 as a decimal? Okay, so it's a vertical line at 7.5. Vertical line at 7.5. 1, 2, 3, 4, 5, 6, 7.5. Vertical line. Alright, figuring out which way it faces based on the information we have now. I can see the directrix is behind it, and it's a vertical line, which should be perpendicular to the axis of symmetry. So I know the axis of symmetry goes this way. Can we tell which way it faces? Right. It is going to face right. Faces right. So kind of something like this. So we can find two more pieces of information just based on the fact that it faces right. Is it going to be x is the squared term or y is the squared term if it faces right? Y. Y is squared. And then what else do we know if it faces right? The sine of 4p. What's going to be the sine of 4p? Say it louder. Positive. Yes, positive. 4p is positive. Okay, so setting up my equation, we only have one squared term on a parabola, and then we'll have our 4p as a coefficient on our unsquared term. And we just figured out that the y is the squared term because it faces right, so my y will be over here and my x will be over here. Was I given an hk already? Yes, we were given an hk because the hk is the vertex. Okay, just remember which one is paired with the y, h or k? The k. So in my y parenthesis, what am I going to write? Plus 5. In my k parenthesis, what am I going to, or in my x parenthesis, what am I going to write? Minus 8. Okay. And then lastly, we know 4p is positive, but we just need to actually find 4p. And you find p kind of the same way we did on this one. The distance from the vertex to the focus is p, but also the distance from the vertex to the directrix is also p. So if you were to count this distance right here, how much is p? 0.5 or a half, yeah. So what's going to go in my line for 4p? 2. Should it be positive or should it be negative? Positive because it's facing to the right. Very good.